Hello, everybody. Thank you so much for joining us. My name is Desmond Martin. I'm the program coordinator here at NextWaveSTEM, and I am so glad to have you with us as we take a little bit of time to discuss the creative process of STEAM using computer-aided design. I know that title is a mouthful, but I'm really excited because we get a chance to get away from what might be considered our regularly scheduled programming. For some of us, we've heard that acronym STEM a whole lot. Science, technology, engineering, and mathematics is something that many of us as educators have been focused on for a number of years when it comes to giving our students some exposure to some different technologies. But more and more in the past few years, we've been seeing another letter in that acronym, A, pop more and more into our collective lexicon. Thinking about ways to engage students in arts is going to be really critical, not only to their own development in their education, but thinking about how we're creating a more diverse workforce and a more prepared workforce and just more prepared students generally. So I'm extremely excited to share some ideas, especially in the context of teaching from home. Before we get started though, I do want to cover a couple of ground rules, and they are very common for so if you've been with the NextWave STEM webinars before. If this is your first time with us, thank you so much. We appreciate you being on with us, and we're hopeful that you will get some information that's really useful. The first thing I want to do is also introduce my panelist, Segundi. She is our school partnerships coordinator here at NextWave STEM, and she is the person to talk to if you're interested in getting more curriculum, the equipment, the training for NextWave STEM programs into your school. Um, for the next hour, she's also doing me a huge favor and monitoring the chat to make sure that I don't miss anything, that any questions that you might have or any comments that you have, make it to me and we get them answered live on air. The second piece of business is for our educators in Illinois. Today is a professional development hour for our Illinois educators. That means that everyone will be receiving, as a part of the follow-up email, a certificate of completion for today's professional development. Currently, we don't have processes in place for states outside of Illinois. That's something that we are working on. But for our Illinois educators, you should be able to take that certificate and log that professional development hour today. Um, but that doesn't mean that we're leaving our non-Illinois educators out of the loop. We're making sure that you have a copy of the slide deck from today's presentation, and there will also be a link to a recording of today's presentation. So that means if I'm speaking a little bit quickly, if you have to jump off a little early, if there's some choppiness in the internet connection, or if I just get a little too excited and we don't get to cover everything today, you'll be able to come back and refer to this webinar on your own time. With all that being said, we will go ahead and press forward. Um, this is a webinar today. I know that everyone is probably incredibly camera ready, but with that being said, we won't be able to see your face or hear your voice. The chat is open. The Q&A functionality is open. So if you've got any questions or any comments, feel free to jump into the chat and Q&A, and we will make sure that we call it out on the air. So a great place to begin is at the beginning. Um, some of you may be really familiar with the NextWave STEM. A lot of you may not be so familiar with NextWave STEM. We are a STEM startup that's focused in education. And we're focused in education because we believe in education. We believe that students need exposure to emerging technologies. That's why for 3 years now, we have been developing and licensing and using our instructors to teach courses in 3D printing, drones, robotics, and computers and AI. We do this K through two, through not two, I'm sorry, K through 12. And the reason that we do this work, that we train teachers and introduce teachers and students to these emerging technologies, is because we believe it is critical, absolutely critical, that our next generation of learners has these tangible skills, not just for their own job placement, not just so that they can excel at the high school and the university level, but because we have some massive, massive, massive problems that we need solutions to. Um, Before, we had to deal with a global pandemic that has forced us to innovate and teach remotely. We had issues of climate change. We had issues of food shortage and food insecurity. We had issues with traffic and how we can get from point A to point B. We continue to have issues of efficacy in the way that we teach whatever subject matter we teach. Um, at NextWaveSTEM, we have seen in the past technology be a huge factor in solving mankind's most pressing issues. And we think that's going to be the truth going into the future as well. So we want to make sure that we empower our students with as much resources as they can, effective learning and hands-on experience with technology so they feel they belong in those fields. And we want to empower you as teachers. We want to let you know that except for the times where we work with rockets, we're not doing rocket science. This is not beyond any of our instructors. This is something that you can learn, be confident in, and project that confidence to your students as you're helping them learn about these amazing technologies. So once again, I'm really excited, really glad to have you with us. To tell you a little bit more about myself, I am program coordinator at NextWaveSTEM. That means that I've been handling a lot of our training for our educators. If you buy our curriculum and you receive training in our specific curricula, you'll be working with me for 6 hours to learn how to actually deliver that curriculum with fidelity. I'm also conducting our webinar series, and I am a curriculum writer in NextWaveSTEM. So I'm really happy to get into the weeds with you with any questions that you might have about our technologies. My professional formal background is in mechanical engineering, and about our specific curricula as well. So I'm really excited for today's webinar. So we're going to cover three goals, three things that I'm hoping that we get a chance to take away from the webinar today. And I'm hoping that you even get a chance to expand upon as you work with NextWaveSTEM material back in your own school or with your students remotely. The first thing is that we want to show some examples of how students would use computer-aided design, CAD, to build skills in the digital arts. Something that's really, really cool is to think about the history of how we make art, or even what art is and why it's important to learn. That's a little bit of a history lesson that I'll give at the top. But then we'll expand, think about where 3D printing, computer-aided design actually lives in that process. Um, the second thing, speaking of 3D printing, is exploring some cross-technological applications for CAD beyond 3D printing. Um, for us at NextWaveSTEM, it's really important to focus on technologies that are emerging, are new, or maybe just new to you, and that are really on the vanguard of where industries will grow into the future. But we don't want to just pigeonhole you into thinking, oh, here's another esoteric thing to teach my students that they may or may not ever use. That would be unfair to you and unfair to your students. We want to focus on the ways that computer-aided design can be really applicable for you, regardless of the actual subject matter that you're teaching, and thinking about different applications that we can see the use of computer-aided design. And then we want to talk about ways that NextWaveSTEM can specifically help you, ways that we can empower students with the tools that they need to do computer-aided design learning at a distance. The program that we're going to use today, some of you may be familiar with it, is Tinkercad. It is completely free to use for your students. It has been from its inception, and it will continue to be for the foreseeable future. It's very resource rich, very powerful, and a great way to introduce both you and your students to computer-aided design if you've never done any before. Um, So we want to talk about ways that NextWaveSTEM integrates that tool into our curricula and ways that you as an educator and as schools and school districts can take advantage of those resources. So we'll jump right into it, thinking about art skills with Tinkercad. Um, Things that your students can actually build when it comes to expressing themselves through digital media. And to do that, it's very useful. There's a traditional saying that says that you can't know where you're going unless you know where you've been. So it's useful to think about art skills in the digital space, even with respect to art history. Um, and in doing that, it's useful to form a definition for that A in that STEAM acronym. We understand science, science being the study of the physical world around us, technology being the product of the understanding of that science to actually make um, a machine that applies power, allows us to do something. Engineering is the part where we integrate math, technology, and science into actual processes and products that solve problems. It's just not about the ability to do something or change something at that point. It's about the ability to actually recognize a problem that human beings have and solve for that problem. And then when we think about math, math is kind of incredible. It's actually a science into itself that quantifies the universe, gives us the ability to define what's happening around us, not just see and understand why it's happening, but know the what of what's happening in the universe. Art is a little bit different because art is something that completely lives in the world of human expression and human understanding. Um, it is about emotional expression. Art is one of the few things that human beings do, specifically designed to make human beings understand or feel specific emotions. And the amazing thing about art is that it's neither linguistic, the things that are spoken traditionally, or written. While there are performance arts, I have been moved to tears by the work of Lauren Hill, for example, or they may be written arts, the works of your favorite playwright. Um, those are art as well, but generally speaking, when you think about working in art through media, we are working through art that's not speaking to us in human language or not musical or reading prose or poetry. A classical understanding of art is things that we are physically making through a media outside of ourselves. And while my formal training is not in art education, I'm doing the best I can with that definition because, like many definitions, it's a fluid one. Art can include lots of different media from lots of different schools of thought and towards many different purposes. The definition that I just shared is the more generalized definition. So don't take that as the gospel truth of what art is. You might want to consult a philosopher for that answer. When we think about art and physical media, we can usually classify that art with regards to classical media. As art was developed through the millennia, art take its shape in three particular areas. Three areas where human beings were making things specifically to communicate feelings or make the observer of the art feel feelings. The first is in sculpture, taking some media and carving that into a different shape, changing the shape. The second is in architecture, goes into the buildings that we build, the structures that are either going to have human interaction or even no human interaction. This is monuments, memorials, tombs, houses. Architecture becomes this important exposition of artistic expression. But then there's also painting. And we're very familiar with painting. Some of the oldest human art that's ever been observed lives in the caves of France, where we see actual painted scenes, things like buffalo and bears and forests, and in this case, handprints on our slide. The reason why I bring up this little piece of art history is twofold. The first is to think about what art will mean for our students in a really holistic way. For our students, art is a form of emotional self-expression. It is an amazing way to develop our students' social and emotional learning. It helps our students be more holistic people, not just students. We talk here at NextWaveSTEM very often about 21st century skills. And for the most part, we are really, really good at communicating and sharing and developing our students those 4 C's, the learning skills. Things that we continue to work on with our students are skills in literacy, when we think about technology literacy or information literacy or media literacy, but also life skills. Art is a tremendous way to help our students build life skills through their ability to do emotional expression. So that's the first reason why I bring up this art lesson. They get to express themselves. But the second reason I bring up the art lesson and really the classical media portion of the art lesson is because according to the classical definition of art, the majority of art is three-dimensional. Sculpture and architecture are three-dimensional processes. If you want to get a little bit technical, so is painting. When you think about the way that paint interacts with a surface, layering paint on top of each other, there's a third dimensionality with regard to that. But to pull back a little bit, when an artist is designing and carving a sculpture, or an architect is designing and then overseeing the building of a structure, it becomes critical that they think in 3 dimensions. And as our art education has expanded, as it's become more formalized here in the US, and we've seen really revolving ways and changes in the way that we teach art in the US, it becomes so critical that our students not lose their ability and not lose the opportunity to do expression in 3 dimensions. That becomes critical. So we're really excited about what even very simple online tools allow for our students to be able to do. So we're going to jump right into it. The majority of my time today is going to be showing you some of the artistic capabilities that your students will have access to in Tinkercad. At this point, I'm actually going to switch my screen share over because like any good cooking show, there's something that's been going on in the oven, and we can just jump right over into it. So this is a Tinkercad design space. Tinkercad is a part of the software suite that's owned by Autodesk. And NextWaveSTEM, we share a partnership with Autodesk and Tinkercad in which we're able to use their tool in conjunction with our curricula. It becomes really, really powerful and really, really useful for our students. And it's designed with 2 thinking modalities in mind. The first is that students should be able to interact with Tinkercad via drag and drop. There is very, very little. I would almost go as far as to say no. And the only reason I put an asterisk on that is because I'm going to show an example, but there's almost no drawing whatsoever done in Tinkercad. It's drag and drop, it's manipulating, it's changing figures in 3-dimensional space. What do I mean by that? Well, what I will do is show an example of that. I have over on the right-hand side examples of shapes, and we'll stick to the basic shapes just for now. What I would do is that I would grab a basic shape like this box and pull it into the work plane. You can see there is an preview of where the shape will land and what that shape will look like. And when I drop it, my shape has been generated. Depending on the shape that you're working with, you'll also have this object pop up, this menu that's called an inspector. Without getting into too much details, the inspector allows us to change different parameters of the shape. I might, for example, um, click on the slider and adjust specifically how long the shape is, or how wide the shape is, or even how high the shape is. So that becomes really useful. But if I click on this arrow to hide the inspector, it's really important to note that the inspector is not your only way of working with the tool. The native way to work with the tool is to actually click on one of these hot clickable dots. The white dots are the vertices, and in clicking on them, I can pull and drag and resize my shapes as I like. If there's a vertex on the top, I can click on that and adjust the height this way. There are curved arrows aligning with the different planes, the x-axis, y-axis, and z-axis, that allow me to rotate shapes. And as I'm rotating, I can see specifically how far I've rotated the shape. I'll rotate this back to flat. And I can rotate about 3 axes very simply. But there's also a height carrot. This cone allows me to actually take an entire shape and float it up in the air or submerge it underneath my work surface. I get to manipulate the shape by a drag and drop any way that I want. And for our students who are looking for precision, anytime I manipulate a shape, I might click on this dot here, and I can click on the numbers inside if I'm being very specific and very particular about where I want my shapes to be. The dimensions of whatever I'm building, I might want that to be, well, not 1,000, that'll be too big, but let's say 125. It will automatically readjust my shape according to the parameters. So that's the first modality. We should be able to drag and drop shapes and manipulate those shapes via pulling and twisting them, almost like we're doing digital sculpting just using our mouse. And it's really useful because in the same way that we learn how to drag and drop and manipulate shapes with our mouse, it's kind of the same modality that allows us to see in 3 dimensions in the space that we're working with. In the upper left-hand corner, there's an object that's known as a view cube. And the view cube is particularly useful because if I click and drag it, it manipulates my perspective in 3-dimensional space. It would be really, really hard if I had to sit in a chair and design a clay sculpture and I couldn't pull my backside out of that chair. If I couldn't look on the back of the sculpture or kneel down and look underneath the sculpture or stand up or look over the sculpture, if I only had one perspective to look at the sculpture, I would not be able to look at that sculpture and see what I'm doing very well. So the ability to really easily adjust my perspective becomes critical. When I click on this home button, and that will actually take me back to my default view. And at any time working in Tinkercad, I can always drag and drop and manipulate the objects that I have. So that's really the first modality, is that you should be able to drag and drop and manipulate objects. Paired together with the second modality in Tinkercad, the way you make more and more complex shapes is through addition and subtraction. Instead of in many other CAD software, where you would design a 2-dimensional shape and then manipulate that 2-dimensional shape into a 3-dimensional shape, everything in Tinkercad starts in 3 dimensions, and you're adding and subtracting 3-dimensional shapes from each other to form more complex shapes. What does that mean, Desmond? You're saying a whole lot there and it doesn't mean anything. Well, let me show you. I would take, for example, this solid cylinder, and I can pull that into the workspace as well. And I'm going to adjust my view just a little bit, and I'll zoom in. So the incredible thing here is that I have this solid cylinder that I can manipulate around. And if I want, I can grab the cylinder and actually run it right into the shape that I pulled out, this box shape. And for the purposes of really making it clear what's going on, I'll make the cylinder taller as well. So now I have this in mesh shape, two shapes that are kind of working together. And what I can do in Tinkercad is highlight, just like I would on a Word document or on iOS or Mac OS or Windows. I can highlight both shapes at once. By highlighting multiple shapes and clicking this tool in the bar, group, I've taken the two shapes and I've turned them into one shape, a more complex shape than we had before. And I can manipulate that more complex shape very simply. Everything is going to scale and follow what I wanted to do. So I've taken two shapes there and I've manipulated them, added them together. Now, the really cool thing about that is that that's adding two positive shapes together to get a more complex shape. But like I said, it's addition and subtraction. So I'm going to break these shapes apart. I'm going to ungroup them. I'm kind of redo the grouping that I did before. Things are deformed a little bit because I was dragging and dropping them and pulling them around. That's okay. I just want to focus on the cylinder, now more ovular, now that I've dragged it and pulled it a bit. This shape is solid, but it does not have to stay that way. In the inspector, I've got some things that I can change. And one thing I can change is where we see this highlighted, where it says solid and it's an orange color. And then we have whole and it becomes this gray stripe color. When I click on a shape and turn it into a whole, what I've done, and I'll focus on the shape, is I've created negative space. This will become a vacuum. Anything that's in there does not actually exist in 3D space. And what I can do is still take this negative space and I will also highlight both these shapes, this negative oval cylinder and this more cube-like shape. I can highlight them both and I can join them together. I can group them. And what I've done is I've now cut a slice out of this shape. This is the basis for the clever, ingenious, really amazing things that your students are going to do with Tinkercad. Adding and subtracting positive and negative space to create some really, really complex shapes. It's not so much about drawing, but it becomes really important that they know the concept of how to move things in three-dimensional space so they can create expressively and artistically. Now, the really, really cool thing about art and really, really amazing thing about art is that sometimes everyone wants to take credit for art. Or even if they don't want to take credit for art, if you're working in a classroom with maybe 24, maybe 30, maybe 31-ish students in your classroom, or even if you're working in a smaller classroom, as you're teaching, you may have some artistic examples that look very, very similar to your fellow students. It becomes useful to sign your artwork. And there are some really useful ways to do that in Tinkercad as well. And I remember vividly when I was 5 years old, well, not even that old. I was 3 years old when I first learned how to write my name in manuscript. And once I learned how to write my name, I wanted to write my name on everything because I wanted to take ownership of all my stuff. I wanted people to know what is mine. Don't take what belongs to me. I've put my name on it so that you don't take it from me. It's a good foundational lesson. It's a lesson about technology and dexterity and skills. It's a social emotional lesson about ownership. But what we also get the opportunity to do is kind of recreate that ability for our students to take ownership of what they do by using what I like to call a digital signature. This is actually one of our lessons in our 3D printing curriculum, is teaching students how to make a digital signature. So what I'm going to do is I'm going to delete this shape, this complex cutouts square cube actually that I've created. I'm just going to highlight it and hit backspace to delete it. And on the right hand side, you'll notice that there is a actual um, shape that's called scribble. There's even a star next to it. The reason why I love scribble is that we have no idea what it does until we try something. And it's not quite what we think it is. So what I'll do is I'll grab scribble, and just like with the box, with the cube, I can pull scribble out into the work area. But something different happens when I drop scribble. When I drop scribble, my screen opens up into this top-down view. And I have this little preview of what's happening according to what I work with in this view. Scribble is the closest that we will ever get to be able to draw a shape in Tinkercad. It's really about freehand expression. And using your mouse, or if your students have a touch screen available to them, they are able to actually scribble out. In this case, I'll use my initials. They're able to scribble out a figure into the space and see that become a three-dimensional representation. So really, really useful tool when we think of something like a digital signature, something that's more free-handed. And the scribble tool allows us to do some of the basic things we need to do. I can grab an eraser and I can erase particular segments of that scribble, or I can altogether define a three-dimensional or a two-dimensional area that I would like to see cut off from the scribble. So I just made the little tail end of my very, very weird signature a little different. In that same way, I can even draw in a more traditional shape using drag and drop as well. But I really don't like the way that looks. So I'll click my undo arrow, Control Z, just like in your word processor, and we'll get rid of that block. I think I'm really, really satisfied with that signature at this point. So I click on done, and I've got this new three-dimensional representation of my signature that I'm able to manipulate like any other shape in Tinkercad. I can drag and pull and stretch and resize. I can float it into the air. I can rotate it however I like to. This becomes a shape, a three-dimensional shape, just like any other three-dimensional shape that I'm now able to manipulate in Tinkercad. So great. We know kind of the way that we expect students to work in Tinkercad and how they're going to interact and operate with different objects in Tinkercad in terms of pulling, in terms of adjusting the inspector. We know that they are going to cut out and add together simple shapes to make more complex shapes. And we know that they can freehand create their own signature that's also a 3D shape that they can use. So what's an example of a really easy thing that students can get into? Well, I am a huge fan. I fumble over this word all the time. I've looked at it and explored it a little bit in the last couple of years. Vexillology. And for those of you who are familiar with vexillology, vexillology is the study of flags. It's the study of the design and purpose and history of flags, those things that fly in the wind over buildings or on the side of vehicles or even in stationery. Flag design, flag use is something that I find pretty interesting. And what I've learned from the American Vexillological Society, yes, that's a real thing. What I've learned about vexillology is that there are some basic design parameters for a flag that make for a really, really good flag. And then if you do the opposite of those things, you can get a really, really, really bad flag as well. So I'm not going to call out anybody's municipality. I won't call out any particular state. But what I will do is focus on an example of a really, really good flag and some of those guidelines parameters. if you're interested in designing a flag, your flag should do a couple things. One, it should not include any small lettering. The reason why it shouldn't include any small lettering is because at a distance, or if it's printed really, really smallly, no one will be able to read it. I'm originally from Michigan. In Michigan, we have lettering on the bottom of our state flag. It's lettering that is Latin that equates to, if you're looking for a pleasant peninsula, look around you. That is a bad design for that part of the flag because if it's flying in the wind 100 feet up in the air, you can't read it. So first thing, you don't want a whole lot of lettering. The second thing is you want to keep your flag color scheme simple, 3 or 4, honestly, no more than 5 colors in that flag. And the reason why you want it simple is for, once again, because you want it to be easily identifiable from a long distance or from really, really close up. Another thing that's really, really important for your flag is that it should be recognizable very easily. So a simple design that's distinguishable with few colors and little lettering, or no lettering preferably, becomes a very, very easy flag to recognize. That's why the United States flag is a pretty easy flag to recognize. You know, you've got 13 stars. I'm sorry, you have 13 stripes. It's only 3 colors, red, white, and blue. You know, there's a blue field in the upper left-hand corner with a certain number of stars. Really, really easy to remember. But it is not the best flag I've ever seen. One of the best flags I've ever seen is actually the city flag for Chicago, Illinois, where NextWaveSTEM is based. It's so good that it's really, really simple, even for a child to see the flag and recreate the design. And that's something that would be a great place to start for your students is if they can remember a flag, if it's the United States flag, or if you're in Chicago, the Chicago flag, or if it's your state's flag, or if they've never seen your state's flag before, maybe they want to get familiar with the state's flag. That's a great place to start. So how easy is it to design a flag, for example, in Tinkercad? Well, it's extremely easy because a flag, especially the city flag of Chicago, is an extremely simple design. Some of you may already be Googling it and might see what happens. I can design the state flag literally by pulling out different shapes, and not a lot of different shapes, into Tinkercad. So I'll start off with the field, just the basic square shape for most flags. Fun fact, the state flag of Ohio is not a square. It is a tapered, I don't even know what to call the shape. It's almost like conical and has cuts into it. But it's not a square. Neither is a flag of Nepal, by the way. We start with this square field for our Chicago flag. I'm going to click on solid and I'm going to change the color because the background color of that field is white. Now, the city flag of Chicago is really simple. It's a white field on the back. There are 2 blue bars running horizontally, one at the top and one at the bottom of the flag. And those blue bars are symbolic. They represent the 2 waters, the bodies of water, the 2 branches of the bodies of water that run through Chicago, part of the Chicago River. And as I mentioned before, those are blue. So I'm going to grab one box and I'll decrease the height of this box a little bit because I don't want to stick it too far from out of my flag. And I'll actually just copy this box that I just made. And I'll pull my copy into the position that I want to see at the bottom. So I've got my white field and I've got my 2 bars. And now for the part that's the most recognizable part of the flag, which is 4 stars. The 4 stars in the middle of the state of the Chicago flag represent 4 major events in Chicago's history. I can't remember them all. I'm actually not originally from Chicago. I'm from Detroit, so I kind of feel weird learning Chicago history as I go. But the founding of Chicago at Fort Dearborn, the fire, the nomination of Lincoln as president, the convention where he was nominated, and then the World's Expedition. I think I got them all for my Illinois history buffs out there. You can correct me if I didn't. But all of these things represent these historic events in Chicago history. What I would do is actually find a simple shape that would be a star. And I can pull my star on to the flag. Now, the interesting thing about the star, other than the fact that the stars are red, is that the stars are particular. They are 6-pointed stars. My star here that I have is 5, but what I see in my inspector is the opportunity to change the number of points on my star. So I can grab the slider and create up to a 30-pointed star, but that's not correct. So instead, I highlight that number and change that to a 6-pointed star. And if I'm remembering correctly, that 6-pointed star isn't just a willy-nilly on the flag. They are in a particular orientation. And that orientation is actually 30 degrees offset. So I have my star there, and I need 4 more. So I can Control C, Control V, copy paste stars. I can use arrow keys to actually bump and move my stars along the flag. And just like I copied or selected multiple items before, I can select multiple items again, select 1 star, select, well, not getting that other star. So I'll try my best to select both stars here. Select 1, select 1 star, and then I'll actually just copy Control C, Control V, my stars across the flag. So just that quickly, if we weren't to go into so much discussion, we've created this 3D representation of the city of Chicago flag, and I can go further in terms of adjusting the little details of this flag to make the flag look the way that I want. Now, if you did this in your classroom with your students, great, fine, amazing, but all your students are going to have similar work, if not the same work. How will they know which work is theirs? Well, fortunately, they have got a digital signature that they can stick on. Now, just how big my signature is, that they can stick into their flag at the bottom. And using the group and changing the color, now their flag becomes something that when they model or when they share with you as a teacher, or even when they 3D print, they can know which is theirs, or they can take it a step further. I'm going to ungroup. And what I can do is focus specifically on my signature. I can actually float it up in the air a little bit and have it enmeshed with my flag a bit. And now I'll turn my signature into a hole when it close so we can see exactly what I'm doing. I'm going to turn my signature into a hole. And now when I take the signature and group it by selecting both the field and the signature at the same time, and I group them, my signature is actually cut out of the bottom part of the flag. So those are just quick examples of something that you can do easily to allow your students artistic exploration in Tinkercad. Really, really fun, really, really short, really, really easy, especially once your students start to play with Tinkercad and learn more about what they're able to do. So let's jump back into that presentation. Which skills transfer into real careers? Tinkercad is completely appropriate for our first graders, second graders, all the way up into high school, including through high school. We'll, of course, expect our students to continue to grow their skills and move on to other computer-aided design software. But we've seen Tinkercad becomes really powerful and is an exposure to the Autodesk suite of software, things like Fusion 360 or Inventor, things that I've used professionally as a mechanical engineer. What are things that we're able to do with these skills in digital art that we can build with something as simple as Tinkercad? Well, of course, product and industrial design. Um, Almost anything that your students have bought off of a store shelf has at some point gone through an industrial design process, an engineering design process, where there's a designer who's going to be drafting in 3 dimensions plans for the way that this final project is going to look. So any field, automotive, kitchen and homeware and tool design, lighting, electronics, aeronautics, flying on airplanes, the way you move, the way you eat, the way you consume entertainment, the way that you work, even the pencils that your students use in the classroom has been 3D designed at some point. Those skills transfer into careers later on. And actually, it becomes amazing to think about the ways in which 3D printing allows for our students to experiment and get hands-on, not to just have a bunch of sketches that live in their brain and on the pad, but become things that they can produce really simply, even in their own home. But we also have the ability to think about sociological work with computer-aided design and 3D printing. 3D scanning. We can go out and 3D scan objects to preserve for historicity, but also because it becomes a powerful way for us to get hands-on with a replica of this historical artifact without either taking it from its historical context or having to travel to a museum. Traveling to a museum, traveling to the Smithsonian would be extremely difficult right now, given the context of a global pandemic. We want to make sure that we give our students those opportunities. And 3D design and computer-aided drafting, computer-aided design is a great way to make that available to our students as well. And of course, there are all kinds of resources that you as educators can connect to continue to build your students' understanding of 3D design and CAD. For one thing, there's file libraries. When you are designing in 3D in Tinkercad, 99% of the time your students will be producing a file called an STL. And that is the standard way that 3-dimensional files are stored for your students. But the thing that's important to understand is that your students are generating STLs. STLs aren't proprietary. Other students are designing in Tinkercad, professionals are designing in other 3-dimensional software, and they're sharing their designs in the Tinkercad gallery and on other websites like Thingiverse, My Manufacturing, and Instructables. These are files that your students can download and experiment and 3D print themselves to get inspiration or to change and modify designs to fit their own needs. It becomes a really, really interesting collaborative research and exploration exercise for your students. And of course, you can 3D print at a distance as well. Online 3D printing services like AstroPrint, MakerBot, if you're familiar with their brand of 3D printers, has a way for you to 3D print directly from MakerBot and ship those prints directly to your students. iMaterialize, Print-A-Thing, and many more will allow you to take, in this case, in this picture, a copy of the city of Chicago flag I just designed and get a quote and get that printed and shipped out to you. This option may be a little bit slower right now because there are a lot of 3D printing companies that are actively making personal protective equipment. They're printing masks and they're printing shields for doctors. So our students' prints may be a little bit less priority for those companies, but that's still an option for you to get these designs, these physical things into your students' hands, even while they're working at home. So at this point, I want to pause for a little bit because I want to give Segundi a chance to step in and talk specifically about how NextWaveSTEM is going to be able to help you really build this artistic skill set when we think about Tinkercad, 3D printing, computer-aided design, and how we can get those resources to your schools. So Sangundi, take it away.
Awesome. Thanks, Desmond. Hey, everyone. Nice to have you here with us. I see a lot of familiar names, so thanks for joining us. So we are doing a lot here at NextWaveSTEM to make sure that we're getting things in front of students. Of course, the first thing that we're doing, and let me just talk about the slide real quick, is PD sessions that Desmond is leading. He has led, I think, upwards of around maybe 20 or more so far the last couple months. So as many of you have attended sessions in the past, you'll see that we cover a variety of topics. So this will continue as listed over here. A couple other things that we're doing is getting instruction in front of students directly. So we have built up our remote teaching capacity. Our teachers are trained and ready to go and doing really well getting this hands-on learning to students with just a laptop. So one option for students and families to choose is an online experience where we have our trained teachers who are also subject matter experts in front of the students, you know, doing the same kinds of stuff Desmond does, walking them through Tinkercad, doing some scratch coding, and it's very interactive and hands-on. So that's one offering. Our second offering is very similar. It's the hands-on experience, and it includes a piece of equipment. So either a robot kit, 3D printer, or a drone. And so families can purchase those and be used, and they can use that in tandem with those online classes. We also work with schools, park districts, youth organizations directly to customize our programming. So if there's any interest there, please let me know, and we'll be very happy to work with you to get all of the stuff in front of kids for the summer. Thanks, Des.
Awesome. Thanks so much, Saguni, for sharing that information. Like Saguni said, we at NextWaveSTEM are really focused on getting you the resources that you need. And we wanted to make sure that those resources were for you, not just for distance learning, but for your classrooms. The curricula are designed to be used at both distance and in person. And that means that we want to give you the flexibility that you need. Because you have attended today's webinar, each one of you is going to have access to the discounted full classroom bundle for the courses that you might want for your students in the fall. That's curricula, that is training, that is the equipment at a discounted price. Reach out to Segundi and she's going to be giving you some more information if you're interested in partnering more with NextWaveSTEM. So I said a lot. I've hit you with a fire hose of information, lots to take in, lots to think about. If you've got questions about our curricula offering or about ways in which students get hands-on and artistic with CAD and even with 3D printing, we'd love to hear more about your questions. So this is the part where I shut up for a little bit, remind you that the chat and Q&A functionality is open, and you can ask anything that you would like. Well, we don't have any questions so far, and that's completely okay. Segundi has dropped in her email address in the chat, segundi@nextwavestem.com. My email is similarly easy. I'm desmond@nextwavestem.com. As I said before, we're sending out a copy of the slide deck from today's webinar. We're also sending you a link to the webinar so you can come back and refer to the presentation today as a personal resource for yourself. Feel free to email us or reach out to us, either Segundi or myself. We are on social media. That means that if you look for NextWaveSTEM on Twitter, LinkedIn, Instagram, or Facebook, you will find us pretty easily. I got an email from someone at TikTok saying NextWaveSTEM should be on TikTok too. I will leave that for somebody else to figure out. TikTok is not my domain, maybe someday. But connect with us, ask some questions. Um, and we are going to be conducting more webinars in the future, as Gandhi mentioned previously. Next Tuesday, we will be exploring making drones real, where we think about ways to get the drones that we use in our drone programs interactive with everyday objects for our students. And this applies to both our students who are working remotely and students who have access to the drone at home. If you're interested in the drone program, that is going to be an awesome webinar session for us to cover and to really get some great ideas. So we're looking forward to seeing you at the next one. Until then, we're hoping that everyone is staying safe, staying well hydrated and well fed, that as you continue to prepare for the end of the school year and going into the summer, preparing for next year, that you're really excited as we are, and that we're continuing to encourage and empower our students in STEM, in STEAM, and well beyond. Thanks so much, everyone, and we will talk to you at the next one. Bye-bye.